We are Daniel Kinitz from the Saxon Academy of Sciences and Humanities
and Thomas Efer from the University of Leipzig.
The ideas that we are going to present all originated in the project Bibliotheca Arabica, hosted at the Saxon Academy of Sciences and Humanities in Leipzig. As a preface, just a few words about the project. Bibliotheca Arabica is a long-term research project on the Arabic manuscript tradition. One of the outcomes of the project will be a graph database system containing data from more than 100 manuscript catalogs. We also include data from biographical and bibliographical reference works, as well as tens of thousands of manuscript documentary notes, which were once added by owners, readers, and other agents. Our aim is to create a comprehensive linked open data resource to support future research in Arabic studies and related disciplines.
In our abstract, we identify several challenges and present the following digital approaches to deal with them. Challenge number one is the integration of heterogeneous resources. This heterogeneity exists on many levels. File formats are either binary or textual in nature and vary widely in the amount of structure and metadata they carry, as well as the tools required to extract such data reliably. Our resources mix tabular and semi-structured data with unstructured full text. They also mix languages, often without making this explicit. Arabic text is represented either in the Arabic alphabet or in Latinized or Romanized scripts using one of several different transcription systems. Left to right and right to left strings of text collide in various configurations, sometimes impeding markup. There is a great deal of heterogeneity at the conceptual and ontological level. Printed catalogs and reference works often only contain an implicit data model with many inconsistencies. Some databases are not transparent about their schema, and sometimes existing standards, for example from the library sector, are reused and extended in a non-standard way. We approach this challenge by putting the integration workflow at the heart of our daily work and by adopting an agile management style to deal with new standards and variants as they emerge, both in terms of modeling the data at schema level and integrating the instance data. This is realized in a source-based fashion thanks to a multi-level ontology that tries to harmonize the semantic gap between the raw input and our final database. The basic data layer for data import is the raw data from our sources. This can be OCR results, database dumps, HTML files, and the like. Layer 2 consists of the transformed data, which has already been atomized and checked for quality. The content of this layer is still heterogeneous in schema, but already machine-readable and well-suited for version control. Data layer 3 is our graph, where the data is modeled in terms of entities and the associations between them. The second of our challenges relates to the final layer of the data integration scenario. We need to model the complexity and diversity of manuscript catalogs while keeping track of the provenance of each statement. These individual statements are called factoids, and we track all the stations through which they have passed until they end up in our database in the form of provenance chains. The basis for formulating such atomic statements is the property graph framework, on top of which we have implemented a system of so-called associations, inspired by the standardized topic maps data model. Associations can connect any number of role players. A simple example is the association of a scribe with the abstract work being written on a specific manuscript as a physical object. Other scenarios involve many more actors, such as pre-modern Arabic teaching situations with a teacher, a reader or reciter, and many listeners. Associations provide anchor points for the reification of relationships, much like RDF star does for RDF data, and our factoid or provenance chains for associations work in a similar fashion to the prof ontology. Challenge number 3 is as follows. We need a very flexible solution for authority control. The term authority control comes from library studies, and we translate it as data-driven identity management. Entities act as hubs for all data relevant to a particular real-world object. The challenge includes to manage conflicting claims about identity and, for example, disputed attributions of authorship. There's a gap between classical central authority records that are manually curated and, on the other hand, a system of linked source witnesses that generate an identified object. In our database system, identity claims are only virtually merged. Any conflicting identity claims are modeled as an association. In practice, this means that contradictory statements can exist side by side.
Challenge number 4 deals with Western-centric data models in authority files and library systems. A pre-modern Arabic person may, for example, have quite complex name variants, with a person name often consisting of 5 to 6 different element types. These complex names are squeezed into a system that is not designed for them, or they simply end up in a full-text field. The same applies to dates in the Islamic calendar format. The standard exchange formats we encounter only know the Western calendar. Any further processing of these dates must therefore first be disambiguated. And accordingly, we cannot use standard exchange formats to export these kinds of data in an unaltered form. The fifth challenge we face is that of scalability and day-to-day performance. We are faced with an ever-growing graph that becomes more complex as our data integration process becomes more sophisticated. Coupled with evidence-based modeling of facts, this quickly leads to performance issues. To address this, we introduced caching mechanisms to minimize query runtimes. We have also implemented a secondary Lucene-based full-text index for node discovery. An ongoing task is the refinement of graph queries to make them faster. As with graph databases in general, performance is output dependent. It is fast for small result sets and slower for larger ones. Therefore, we are going to introduce more live indicators on the web portal that allow users to estimate the remaining query time. The last challenge we want to mention is a conceptual one, arising from the conflicting objectives we want to pursue. We need to present a robust database that is user-friendly and can serve as a reference for researchers. At the same time, we need to use the system as a research-driven prototype that helps us to evaluate and implement the latest technologies. In a sense, we are building the car while we drive it. We approach this challenge with a compromise. We embed an experimental graph database in a simpler database environment based on technologically mature components, trying to combine the best of both worlds. After all these technical challenges, we would like to conclude our presentation by pointing out the main challenge of our project. We want to question traditional narratives about the decline of Arabic literature after the so-called Golden Age. To do this, we need lots of data, all the data we can get, as clean and unbiased as possible. Therefore, we need either more manpower or more computing power, or perhaps both. The next few years will show whether the best way to achieve this is through increased efficiency, through collaboration, or through large-scale citizen science approaches. Thank you very much for your interest in our presentation. Please do not hesitate to question or to comment.